Welcome back to Behavior and Environment. We'll continue with Objective 11, identify relations between fundamental properties and dimensional quantities of behavior. And this is video part 5. ASR 21, which fundamental property enables measurement of latency? Is it A, temporal locus, B, temporal extent, C, repeatability, or D, a combination of repeatability and temporal locus? A couple more seconds. Alright, I'll go ahead and close the poll, and the answer here is temporal locus. Temporal locus means that a response occurs at a point in time in relation to a preceding environmental event, and so that's a property that you can quantify. The dimensional quantity is latency, the time between that preceding environmental event and the onset of the response or the response cycle. ASR 22, which fundamental property enables measurement of duration? A, temporal locus, B, temporal extent, C, repeatability, or D, the combination of repeatability and temporal locus. A couple more seconds. Alright, I'll close the poll, and the answer here is B, temporal extent. Temporal extent is that a response occupies time. And because a response occupies time, you can measure the beginning, middle, and end, and that's duration. ASR 23, which fundamental property enables measurement of rate? A, temporal locus, B, temporal extent, C, repeatability, or D, the combination of repeatability and temporal locus. A couple more seconds. Alright, I'll close the poll, and the answer here is D. ASR 24, which fundamental property enables counting multiple responses? A, temporal locus, B, temporal extent, C, repeatability, or D, the combination of repeatability and temporal locus. A couple more seconds. Alright, I'll close the poll. The answer is C, repeatability. That means a response can reoccur, and because a response can reoccur, then you can count multiple responses. Objective 12 is given scenarios, select relevant dimensional quantities. So here you're applying what you've learned about dimensional quantities to making decisions about what you would measure in a given situation. ASR 25, the student takes too long to start the math assignment when the worksheet is placed on their desk. Which dimensional quantity should you measure? A, latency, B, temporal locus, C, duration, or D, rate? Give you a couple more seconds. Alright, I'll close the poll, and the answer here is A, latency. So it says the student takes too long to start the math assignment when the worksheet's placed on their desk. So think of the class as the environment, the desk is the context, the stimulus is being presented with a worksheet. So then it's to start the math assignment, so the time between when the worksheet's placed on their desk till they start the math assignment, that's the onset of the response cycle, so that's latency. You would measure latency. ASR 26, the student stood in line for 5 minutes waiting for the teacher to bring him back to class from recess. 5 minutes represents which dimensional quantity? A, latency, B, temporal locus, C, duration, or D, rate? Give you a couple more seconds. Alright, I'll close the poll, and the answer is C, duration. ASR 27, your employee, a cashier at a grocery store, scans items too slowly. To improve their performance, you will need to measure and increase which dimensional quantity of their item scanning behavior. Is it A, duration, B, count, C, rate, or D, repeatability? A couple more seconds. Okay, I'll close the poll, and the answer here is C, rate. That is the number of items they scan per unit of time. ASR 28, the student raised his hand 6 times. Which dimensional quantity was measured? A, IRT, B, count, C, rate, D, repeatability. A couple more seconds. Alright, I'll close the poll, and the answer here is B, count. It's not rate because the passage of time isn't referenced here. They're not saying that he raised his hand 6 times per minute. It's just 6 times. It's not repeatability because that's a fundamental property. So the dimensional quantity that was measured is actually count or countability. ASR 29. The student raises their hand to answer and ask questions frequently in class, but in fact it's too frequent, so it's disruptive. And so it's being addressed in an assessment, and so the paraprofessional in the classroom wants to know how much time on average passes between instances of hand raising. She should calculate A, the IRT, B, the count, C, the rate, or D, repeatability. Give you a couple more seconds. Alright, I'll close the poll, and the answer here is A, IRT, because in this scenario the paraprofessional is interested in how much time passes between successive responses. That's IRT. IRT is can be measured based on the fundamental property of the combination of repeatability and temporal locus. And she wouldn't measure rate because she's not interested in how many times per minute or how many times per hour the behavior occurs. She's focused here on the average amount of time that passes between instances. That's IRT. Alright, so an early step in deciding what to measure is defining the behavior you want to change or teach, and we call that typically the target behavior. And so target behaviors can be defined based on topography or function. The topography-based definition identifies instances of the target behavior by the shape or form of the behavior, what it looks like. A function-based definition designates responses as members of the targeted response class solely by their common effect on the environment, or their the effect on the environment, the change in the environment produced by those responses. So you have topography-based definitions and function-based definitions of behavior. Let's look at topography first. Objective 13 is to define topography. Well, topography is the physical form or shape of a behavior. That's from Cooper, Heron, and Heward in 2007. It's the exact structure of the behavior or what it looks like. And this includes, or can include, magnitude, severity, and intensity of the behavior. That's from Jose Martinez-Diaz, 2013. And here are some examples of topography. So hitting own face with an open hand with sufficient force to produce a sound. Or hunched over the computer while typing. Throwing paper at the teacher. Writing the word January with an uppercase J, or smiling with eye contact as opposed to smiling without eye contact. Placing a shape into the shape sorter with the right hand. Taking 5 or more steps away from the teacher and laying on the floor. Those are all examples of topography. Let's look at function. 14 is define function. It's the effect of behavior on the environment, and I'm going to say the same thing like 4 ways here. Okay, so the effect of behavior on the environment. Also, it's the change in the environment produced by a response. It's the consequence of a response. It's the consequence part of a behavior. So I said the same thing in 4 different ways here to hopefully you'll be able to develop this concept quickly here of what function is. It's the effect of the behavior on the environment. So here are examples of functions. If an infant crying results in parent feeding, the parent feeding the infant is the effect of the infant crying. That's the result of the infant crying. If you flip a light switch, the light turns on. So the light turning on is the effect of that response. If you turn down the air conditioning, the room warms. So the room warming is an effect of that behavior, that response. You put a toothpick in your tooth and the food comes out. Food coming out is the effect of that response. A kid hits the plate off the table at dinner and then dad stops asking the child to eat their vegetables. Hey, that's another change in the environment produced by behavior. Child jumps on the skateboard, child's on the skateboard. Okay. Notice I didn't say the child jumps on the skateboard and then the child is riding the skateboard or skateboarding. Because riding the skateboard or skateboarding is still behavior, so we have to be really careful when we distinguish between what the what the behavior looks like and its effect on the environment. So child jumping on the skateboard is what it looks like. But child is on the skateboard as opposed to not previously having been on the skateboard. That's the change in the environment, right? So first child was not on skateboard, then they engaged in the behavior of jumping on skateboard. Now they are on skateboard. That's the change in the environment, the effect of the behavior. Similarly with when the parent feeds, the infant stops crying. So what I really, really want to highlight here is that all of these effects on the environment by the behavior, those are stimuli. They're stimuli we classify later. We'll talk about this as consequences. And a stimulus is a change in the environment. So the effect of the behavior on the environment is a change in the environment from one state to another. So when you're trying to figure out, well, what's the effect of the behavior on the environment, sometimes you have to imagine what was the environment before the behavior occurred, then how was the environment after the behavior occurred, and the difference is the change. So first the infant was crying, then the parent fed the infant, and then the infant stopped crying. So what's the effect of parent feeding the infant? It's that it stops the infant's crying. That's the change or the effect on the environment. Okay. ASR time. ASR 30, you plug the hairdryer into the wall by picking up the cord with your right hand and then reaching to the outlet and aligning the prongs of the plug with the outlet. This is a description of A, topography, B, function, or C, neither. Give you a few more seconds. All right, I'll close the poll. The answer here is A, topography. Now, if I said after plugging in the prongs into the outlet, you press the button and then the hairdryer turned on, the hairdryer turned on would be the function part of that scenario. Okay. ASR 31. You opened the mailbox, the mail was inside. The accessibility of the mail now is A, the topography of the response, B, the function of the response, or C, neither. Give you a few more seconds. Alright, I'll close the poll, and the answer here is the function of the response. First the mail wasn't accessible, but then you open the mailbox, and there it is, now it's accessible. That's the change in the environment that was produced by the behavior. Alright, so let's move on to objective 15. This is define response class. Now, I want to read you a quote about response classes from Johnson and Pennypacker's text in 1993 on page 70. They said, response classes originate and evolve from the natural forces that control behavior. Mediated by the biological process of reinforcement, the environmental events that surround behavior organize its endless permutations into distinct groupings. And it is these natural forces at work in the ebb and flow of behavior that provide us with non-arbitrary means of identifying particular response classes within the complex stream of an individual's behavior. Alright, so we can define a class of responses as a grouping of individual actions or responses that share those same commonalities in the class definition. In other words, what Johnson and Pennypacker were saying is that a response class is essentially just a set of responses that you group together based on a particular definition. Okay, and we mentioned before that behavior can be defined in terms of its topography or its function, right? So there are topographical response classes and there are functional response classes. Types of response classes are topographical response class and functional response class. Just depends how you're defining things. And we're going to look at those in more detail here coming up. So first what I think I want to do is I want to end this video part here, and then we'll resume the next video part beginning with objective 16.